What I want to look at here is the difference between simple interest and compound interest. This isn't just good for your GCSE maths, this is useful in everyday life, understanding the difference between these two different concepts. So we're going to use some very simple numbers so that we don't get tied up in those. We're just going to try and grasp how you do the different calculations. What we're going to say is that both of these people have put £100 into their bank account. Both of them are offered a 10% interest rate. Not realistic these days, but like I say, it keeps the numbers easy. So they've both done exactly the same thing. The only difference is that his bank is offering him simple interest and her bank is offering her compound interest. Now let's think about what happens. At the end of year one, his £100 will have gained another 10%. He will have £110. Exactly the same thing has happened here. Her £100 has gained 10%. She has £110. The difference lies in what happens to that money. In this guy's case, his £100 is still in the bank and the £10 goes into his pocket. In her case, all of the money stays in the bank, unless of course she decides to remove it, but we're assuming that they're leaving the money in the bank if they can. He isn't allowed to leave it in the bank, this interest. He must take it out. That's just one of the rules. And so they've both got a total of £110 at the end of the first year. It's just that it's split differently. He's got £100 in the bank and £10 in his pocket. She's got £110 in the bank and, if you like, nothing in her pocket. We move on to the end of year two. Now, he's got £100 in the bank and he gets 10% of that as interest. So he gets £10. So he still has £100 in the bank, but he's now got £20 in his pocket. He's now totaling £120 instead of £110. But she has £110 in the bank and she gets 10% interest of £110. Now that's £11. So she goes up by £11 to £121 in the bank and nothing in her pocket. And you start to see the difference coming into play. He's got £120 in total, split between his bank and his pocket. She has £121 just in the bank. And every year the difference grows. The end of year three, well, he's got £100 in the bank. He gets 10%. He will get another £10. So he's now up to £30 in his pocket. That is, between the bank and his pocket, he has a total of £130. She, on the other hand, gets another 10% of this. Now 10% of that, it's a bit awkward, £12.10. She's now up to £133.10. And so you can see that she's doing a bit better. It might not seem like much, but actually over the years it'll really, really add up into a sizable difference. This is why, on a practical note, you should look for compound interest accounts when you're saving your money. It's also why you don't want to take out loans that you don't need, because they will apply compound interest and you will owe more and more. Not so good. Now, the question is, how do we actually set these sums out? In a funny way, the compound interest is actually easier. What we can say is that she starts out with £100, it goes up by 10%. These are percentage multipliers that we've seen previously. It goes up by 10%, and it does that every year. So times 1.10, times another 1.10, times another 1.10 for as many years as she leaves the money in there. So for 3 years, it's going to be a power 3. And that, nearly done, that will work out for you exactly how much money she has after 3 years. Here, on the other hand, you've got to do it in a slightly more complicated way. 10% of £100 is £10. For 3 years equals £30. And so the total that he has is the £100 that's been sitting in the bank all this time, and the £30 which has grown in his pocket. He's up to £130. So although compound interest leads to more complicated numbers, often the calculation that you do is a little bit less long-winded. Whenever you do one of these questions where you have to compare simple and compound interest, try to picture it as money in the bank, money in the pocket for the simple interest person, and only money in the bank for compound interest.